Okay, welcome. So in the last lecture, we talked about even functions, which are really nice that they're symmetric across the y-axis, but the integral, it's just that it's double of the integral from 0 to a, really, because of that symmetry. This one is actually going to be even nicer because you're going to get 0. So this is going to be very convenient because sometimes you might not know how to deal with a function. Other than that, it is actually an odd function. Okay, so if f is odd, again, we're supposing that f is continuous on that symmetric interval. If f is odd, then, oops, sorry, if f is odd, right, and then what's the meaning of odd? So this is where you're going to have that. So now, right, we want to know what happens when we take the negative of something. And in this circumstance, you're actually going to get negative of it. Oops. Okay. So we're in this sort of circumstance, okay, which is to kind of say that we're flipping if we flip the input sign, then we flip the output sign. Okay, so this is like saying that flipping the input sign flips the output sign. Okay, then we're going to have that the integral from minus a to a of this function f of x dx is actually going to equal 0. So this is very kind of powerful. It definitely helps a lot with computation. So let's kind of look at an example. So just like in the other circumstance, if you take, so we took even powers, we got even functions. It's actually true if you take odd powers, you get odd functions, which are kind of nice examples. You could also use sine of theta, actually. Okay, and then, so let's just draw. Right, again, we always get something that looks kind of like this. It's just kind of a matter of how steep it is or whatever. But we'll just say that this is y equals x cubed. Okay, and if I looked, for example, from minus 1 to 1, okay, and I looked at these areas, right, they're the same area but with opposite signs. So these are the same areas. Trying to figure out how to, okay, these same area, opposite sign, so cancel. Okay. So let's kind of look at that. It's kind of fun to actually show it to you. So we're going to take the integral, and we're going to go from minus 1 to 1. So that's a good one because those are minus of each other. So we start going minus 1 to 1. And then we're going to take up x cubed dx. Okay, well this is, so we're going to get x to the 4th over 4. We've kind of been doing a lot of examples, so I didn't kind of work that through for you. But we go, and then we're going to want to go from x equals minus 1 to x equals 1. Right? Which is to say, right, so how do we do that? As we all by now know that my preference for how to do this to make sure I'm not making mistakes is to go through and just put parentheses here with my function. So I just replace my x with parentheses. I do the same thing over here. I put in the 1 first because that's the upper, so upper goes first. Lower goes next. Okay, and then we're going to have that this is going to equal So this first one here, so this is 1/4, and then this is actually going to be 1/4 also. So we're going to get 1/4 minus 1/4, and it's 0. So that actually works out exactly like we want. Okay. And again, we're going to have more examples of even functions are going to come from, sorry, more examples of odd functions. So more examples of odd functions. Okay, so we actually have, so it's going to look the same except that now the powers are odd. So anything that looks like f equals x to the k, where k is odd. Right, so you can remember this because those are odd functions. You can remember the name that way. So for example, we could take like, right, f of x equals x. Well, f of x equals x works actually, or x cubed, or x to the 5th, or anything like that. Okay. And then here's kind of a caution or a warning. I like the Italian style of doing this, where you get like, that's a nice, it's like warning. It's a nice kind of picture. Okay. So if I take minus 2 cubed and I add 1, I get minus 7. Okay. If I take minus 2 cubed plus 1, then I'm going to get minus 9. Okay. Now, why am I doing this? Because sometimes people, they say, well, what if I put a constant there or something? Since these are not equal, then the function f of x equals x cubed plus 1 okay, so this function is not odd. Okay, so it's not any function whose highest power is odd. It actually really has to just be like x to the whatever. Okay, there are other examples, such as the sine function will actually satisfy this too. Okay, and you test them, right, by putting in, and part of the reason I did this also was to test this. How do you test if something is odd? And I tested it's always true that for every value, if I put in minus that value, like I did there, then I get out the same thing as if I put in the positive value and put a minus in front of the whole thing. Okay, so great. So this is just some kind of fun kinds of functions that like give you 0 as your integral, so that's really easy to compute. So it's kind of nice to know about them and to kind of understand how functions can look a little different and behave a little different. So great. I hope this made sense, and I will see you in the next lecture.